Okay, sorry about that, John. This will definitely be the last one. So, that's all the code that I worked on. Well, I worked on more code, but I want to finish this up. So, that was the hardest part of the code. So, the game state synchronization. So, how is the data sent over the network? So, how the data is sent over a network is if you start with the client side, and we have like a notify player spawn. So what happens here is that the first thing that happens is that it will go through the list of peers, and then if one of the peers is ready, it will create a packet, and then it will get the server the packet type which is related to player connect, and then it will create an int32, which is the basic standard for the player player identification, I'm going to assume. And then it will and then it will add that to the packet, and then in the packet it will also make, there it is, a player identification, and using the player identification it will use the player X, and it will get the player Y as well, and then it will say get the peer that you're sending to and send that over the socket. Now, and that's when the game server would send it over, and then on the other end the game state, or the multiplayer game state, will receive that, and it will create a aircraft identifier, aircraft position, int32 and vector2f, which relates directly to this section here, which is a int32, and I'm not sure where the vector2f is, but it should be somewhere there. I think maybe it's initialized automatically because you're adding in two things. Anyway, so then either way, so then you create a vector2f, and then you basically pull that from the network and from out of the packet, and then you create a reference to an aircraft, and then add that using the aircraft identifier, and then use the add aircraft into the mworld setting, and then you set the position using the aircraft position that you took from the vector, and then you add the identifier to the list of aircraft identifiers in MPlayers. So that's how the game state serialization works from start to finish. How it worked in the actual demo was relatively okay. I think considering, I think we had a good few players on. I think at one point we had 6 or 12 players on, but the movement was very bad, and they all spawned in the same spot, and they all matched the fire key, which basically made it very hard to keep the connection open, and it was lagging very bad. So that's the game state synchronization. Let me just see if I'm hitting everything. Game persistence. So this is one of the large failings of this, which was very bad, seen as game persistence was something we could have done very easily, but I think the idea was our fault was that we presumed it was such not an easy thing to do, but an easy thing to do, that we left it to the last minute, and then we didn't have time. So what we'd want to do with the game persistence is output any necessary data out to the file. So if you're going around as your player and you're shooting people, you would maybe have a high score, and then you get 50 points for every person that you shoot, and then they're all read out to individual files on the person's client, and then when at the end of the game, when the last person is standing, the amount of players is the high scores are totted up, and then the person with the highest score is the winner. And that's how our game persistence would have worked. You could also use it for different things like health and thing as a backup in case a player lost connection, that you could just put them back in, but put them back in without a fresh set of health, and put them back in with the same health in the same position, roughly around that. That's what you want to do. So then the bandwidth. So I'm not really particularly sure if this is the correct sum. I don't think it is. So the idea would be, or even how it's approached, but I took a swing at it anyway. So for the bandwidth, the requirement is that I'd be able to tell estimation of the bandwidth requirements and how many players the game can support on the DKT and other networks. So me and the team forgot to check the speed of the network in DKT before we left. So this is the speed of the network in my own home. So download speeds are 15.68 and the upload is 9.59. So what I've done here is use the formula of bandwidth divided by number of players squared times the packet size. So this is here, screencast 16. Yeah, so in this situation I'm using the player real-time change packet. So if this packet was being sent over and it was being sent over to the max amount of players that we have right now, which we're allowing, which is 10, that would give us 15.68 divided by 6500, which would give us bytes per second of 0.0024 bytes. That figure seems very low to me, but I'm not sure. I'd assume that you could maybe get 20. No, I'd say about maybe 2000 bytes a second. Hopefully, I'm not too sure. And then on the upload side, it's the same. It's I think so. I think my calculations are wrong here. However, okay. So lastly, the TCP, how that affected the game. So the TCP had drastic effects on the game, seen as the it would send every single packet that you wanted, as I said here. So it would send every single packet regardless if you wanted it or not. So one of the issues there is if I'd press the bullet or the shoot button for the bullet to be triggered, and then 5 seconds later the packet would only come to me then. At that point I don't need it and I don't want it, and it's just bunking it up. So you saw that when all the players happened and then they all pressed space at the same time, that these packets were all been waiting, and then it just became huge lag because the TCP was sending over packets that were being sent at the start of the game, like a minute into the game. So that's what the effect of TCP has. Hopefully when we get the UDP to work, we'll be able to set like the packets into constraints for that. One of the possible fixes is that you could limit the amount of functionality in the game. So you could limit it that like the players are only allowed to shoot like once every minute and then add it in. I think that's one of the things that we're trying to do with the game, is that you can only shoot every 30 seconds or so, and then so you might only have 8 bullets, so like you sort of have to be sparingly with them. Yeah, so that's my screencast. Sorry it took sorry that was so long. I didn't want it to. I wanted to just make sure everything was covered because I was hoping to get as much marks as possible, actually. Then gameplay, in-class demo, screencast version, yep. So you also said to add in improvements that we could possibly have. So yeah, I think definitely improvements that we do for the next one is, well, first thing we'd have is like a fully functioning game. That everything. I think one of our faults was we tried to make the scope too big, even though we did reduce the scope. I think the scope should be reduced drastically. Looking at Donnie's game, I think Donnie's game is a great example of that. Like, I think he doesn't even have a collisions, or he does have collisions, but he doesn't have like objects that you can hit off of in the game, which is, it's good. And it's I think his movements and his mechanics are really simple. So that's because I know he had trouble with it. So yeah, maybe we can follow his example. And yeah, I think it's even at the worst case scenario, we could just have 15 people playing in like a room with just like sort of objects in the area, and you sort of have to dodge, shoot people like while like not making sure that your bullets don't hit the objects, stuff like that. Yeah, I think that's what we'll do. In terms of this, I think we'll probably depending on how the classes go, we'll leave TCP stuff now and just work on UDP, trying to get that really, really good. The benefit is now that we have like a lot of time between now and then. So like if it's today and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I think it's after that 11, 12, 13. I'm not sure when exams are, like, so maybe the 12 weeks away. So hopefully we'll be able to do something definitely with that. Improvements would be if we just set aside maybe 3 hours every week just to go straight into multiplayer, because if the whole team, me, Patrick and Zillan, and then I'll just tell my team project team that just is necessary, and that's just the way it is. Okay, well, thanks very much for listening, and again, sorry it took so long. Okay. Thanks, John.